No? So as we are going to see classification and detection of anomalies. Anomaly is a term that can lead to inconsistencies in the data flow analysis. The process of the data flow from one statement to another statement. If there is inconsistency of data rises, then that will be considered as an anomaly. Whenever the data flow is referred, so in the process of the reading variables, if the program or the programmer having without having any idea from where that variable is taking the value, first of all whether that is declared, initialized, or how it is going to use, how the data is accepting the values. In this process, if there is any inconsistencies rise, then that will be considered as an anomaly. How this pattern anomalies are classified and how we are going to detect that anomalies, that we will see in this class. The process of the data flow anomalies, each and every variable that is declared is referred and inspected. There will be different variables in the process of data flow, and those variables will be classified into either defined variable or referenced variable or undefined variable. Means defined variable will be represented by d small d. It indicates that values assigned to a variable. Value is defined for a variable. Next classification is a referenced variable, which can be represented by R. It indicates that value is read or used by a variable. D is we are assigning a value. Here R is we are reading or used by a variable. Third classification is undefined, which is represented by D. Means if any variable that is not initialized with any value, so that can be undefined value or undefined variable. Depending on these classifications, these three classifications, which is defined, referenced and undefined, the data flow anomalies can be distinguished in 3 types. One is UR anomaly, DU anomaly, and DD anomaly. UR anomaly, DU anomaly, and DD anomaly. Undefined referenced anomaly, defined and undefined anomaly, defined and defined anomaly. These are the 3 types of anomalies, data flow anomalies. We'll see one by one. UR anomaly. So during the data flow anomalies analysis, if the undefined value of a variable is read, then it is known as UR anomaly. When a variable is not initialized with any value, but we are trying to read that value, that is UR anomaly. DU anomaly. A defined variable becomes invalid or undefined variable when variable is not used within a particular time. any value is declared as a local variable of some function, but it is not used, it means we initialized, we have defined some value to a variable, but it is not used anyway. That comes under the DU anomaly. Within the specific time or nothing but within specific area or particular block, if any value is not used but declared, it shows that DU anomaly. And DD anomaly. This anomaly occurs when the variable accepts a value at the second assignment instead of the first assignment value. For suppose at starting I initialized the variable int a is equals to 10. After few statements I initialized a is equals to 50. I am reassigning the value 15 to a, but the first assignment whatever the value is 10 for a, that is not used. Without using the first assignment value, I am reassigning the value to variable, some variable, that is DD. For example, let us see here. So here some example is there. See here, a is equals to 7 and a is equals to 11. And if you see here, so some function is there, some function definition is there. Here int get, if a is greater than b, b is equals to get, b is equals to a, get is equals to a. We will see one by one anomaly. UR anomaly. In the above example, the variable get is used on the right hand side of the assignment. The variable get has a undefined value. It is not initialized where it is declared. Undefined value is reading. So the variable get is used on the right hand side of the assignment. See in the example. B is equals to get. B is equals to get. So here the get is declared, but it is not initialized with any value. It means it contains some garbage value. But I am assigning this particular get to B. It's a right hand side assignment. B is equals to get. B is assigning with get value, but which is get has no value. So it is a UR anomaly. Undefined value is going to read or assigning to some other variable. It is a UR anomaly. Next is DD anomaly. The variable b is used twice on the left hand side of the assignment. The first assignment value becomes invalid or unused, and the second assignment value is taken or used. We will see in the example. See here, b is equals to get and b is equals to a. For suppose, if get has some value, say get is equals to 5. Here, b is equals to 5. Get means b is equals to 5. And b is equals to a. A is equals to 7. Say for suppose, say it's a 7. In the above statement, in the first statement, b is equals to get, which is reading the value of get, it's 5. And I'm assigning the b in this immediate statement. In the statement, I'm reassigning the value a to b. Here, whatever the value that is assigned before b is equals to get is not used. Then use shell element. B is equals to get a value ni we didn't use. But we are reassigning with a. That is a DU anomaly. Sorry, DD anomaly. And DU anomaly. The variable get has defined value in the last assignment. The defined variable cannot be used anywhere in the function because only those variables are valid which are inside the function. Therefore, the unused variables results in DU anomaly. See here. At last, here get has no value. Here I am assigning the get with a. Get is equals to a. but this particular exchange function definition is closes here. At the end of the statement, I am assigning the value to get, which is not used. I am assigning some value to get, but I am not using the value of get to anywhere, nothing but after the statements, because it is the last statement here. What has value will be within this function. It cannot be used outside the exchange function. This is a DD, DU anomaly. DU anomaly. These are the three anomalies for the data flow. So it's a classification and detection of anomalies. If there is an anomaly, once again I am saying that anomaly is nothing but in the process of data flow analysis, if there is any inconsistency rises in defining or in reading or in assigning a value to a variable, this inconsistency will be considered as an anomaly. And the classification is three types. One is defined, referenced and undefined. And whereas the detection of data flow anomalies is also distinguished in three types. One is UR anomaly, DU anomaly and DD anomaly. I hope you understand this topic, classification and detection of anomalies. So in next class, we come with another interesting topic in software testing. Thank you. Bye. We'll meet in next